हेलो फ्रेंड, आज हम केमिकल बॉन्डिंग का लेक्चर नंबर 3 लेकर आए हूँ। ये टॉपिक्स बहुत इम्पोर्टेंट है ऑर्गेनिक एंड इनऑर्गेनिक केमिस्ट्री के लिए। चलिए स्टार्ट करते हैं वीडियो। द टॉपिक्स नेम इज केमिकल बॉन्डिंग overlapping method of hybridization. We previous lecture learned that the hybridization of central atom by the formula and the short tricks, but this procedure can help you for the board exam for class 11 board exam CBSE and ICSE. The overlapping method of a particular compound, hybridization of central atom. Suppose an example for PCl5. Suppose an example of PCl5. What is the hybridization state of central atom? But this method is overlapping method. This is the elaborate process for the board exam. First time, point number 1. First time, write the electronic configuration. Write the electronic configuration of central atom. Configuration of central atom in ground state, Number 2, then the configuration of excited state Then last process is surrounding atom are bonded with atomic orbital. This is the 3 procedure. Atomic orbital. This is the 3 procedure for overlapping method, determination of hybridization for central atom in a given compound. First time you write the electronic configuration of central atom in ground state according to Aufbau principle. Then next process, the configuration of excited state. Then last process is surrounding the atoms of bonded with atomic orbital. This is the 3 procedure. Next procedure, follow this system. First time, central atom configuration, ground state configuration. First time, ground state configuration of central atom. Ground state configuration. We know that phosphorus, atomic number of phosphorus 15. So according to Aufbau principle, the configuration is 1s2, 2s2, 2p6, 3s2, 3p3. This is the electronic configuration of central atom phosphorus in its ground state. 1s2, 2s2, 2p6, 3s2, 3p3. Total number of electron counted, uppermost number 2 to 4 to 6, 2 to 4, 6, 10 to 12 plus 3, 15. This is the ground state configuration. Then next process, draw the atomic orbital and its electron by Hund rules. 1s2, maximum number of electron in S subcell, maximum number of electron 2, but the 2 electrons are occupy always 1 clockwise, 1 anti-clockwise. That means spin resonance. Then next orbital 2s, maximum electron orbital occupy in s orbital always 2. One orbital, one electron are clockwise and others electron are anti-clockwise. Next 2p, 2p maximum vacant shape 3. The p subcell occupy 3 vacant space. One name is 2px, others is 2py, next last is 2pz. Total vacant space 3 for p subcell. Total number electron 6. First time, according to Hund's rules, first time 1 electron are added in each space. The remaining electron are occupied, then paired condition. Total 6 electron. Next orbit is 3s. This is the 3s configuration. Total 2 electron, one clockwise and one anti-clockwise. This is the 1s, this is the 2s, this is the 2p. Then this is the 3s. Last 3p. P subcell means total vacant space 3. Their name is 3px, 3py and 3pz. Total electron 3. First time, according to Hund's rules, 1 electron can fill up by each space. This is the 3p. Then we only taken the outermost orbital, that means vacant shell, that means valence shell. What is valence shell? The outermost shell of an atom is known as valence shell. The electronic configuration shows that the principal quantum number 3, this is 3, this is the principal quantum number are equal, and it in the configuration of 2 orbital 3s and 3p are outermost orbital due to same principal quantum number. So this is the valence shell. So the valence shell name, valence shell is 3s2 3p3. 3s2 3p3 is valence shell. What is the procedure of identification of valence shell? The outermost shell. The outermost shell are 3s 3p, but they are thick. Its previous shell is 3s, equal number of principal quantum number. So this is the outermost shell, valence shell. So we can take in only valence shell configuration. So we shall take in only valence shell configuration. Then ground state, then the excited state. What is excited state? What is the meaning of excited state? That means, what is the meaning of excited state? That means a metal surface. Suppose a metal surface, this is made by any metals. This is made by any metal. Then the photon particle from the sunlight, then this metal rest condition, in rest, ground state configuration, in rest ground state configuration. But when the photon particle are fall in waveform, fall in waveform on the metal surface, this is the photon. Photon, that means light of particle, photon. The photon particle are emits from sunlight and it's fall on the metal surface. Then the electron of the metal are excited and they are released from, this is the electron, then they are released the metal surface. Then this is the electron are released from the metal surface. This electron is known as photoelectron. And this state, when the photon particle fall on the metal surface, then the metal electrons are, then the metal's atomic orbitals electrons are excited and the electron are jumped from the metal surface. These electrons are known as photoelectron. This is the condition of excited state. But we taken in this case, only the configuration of outermost shell when the electron are jumped from their metal surface. That means 3s2 3s2 3p3 3s2 3p3. This is the outermost cell configuration. The remaining vacant cell, the phosphorus has vacant d orbital. The phosphorus have vacant d orbital. D orbital occupy maximum empty space 5. This is the d orbital. Phosphorus contain vacant d orbital. The d orbital cannot occupy by the electron. These space are empty space 3d. Any d subcell contain maximum 5 number of empty space. Each space contain maximum number of 2 electrons. That means total d subcell contain 10 electron. This vacant d orbital also be drawn in this position. 3d 5. 3d 5. What is the 3d? Empty space 1, 2, 3, 4, 5. Any d subcell contain 5 empty space. What is the name of the empty space? What is the name of the each empty space? This is the 5 empty space name is 3d xy, 3d yz, 3d zx, 3d x square minus y square and 3d z square. This is the 5 empty space name. 3dxy. What is the diagram? What is the diagram of 3dxy? What is the diagram of 3dxy? With the 3dxy, the d subcell shape double dumbbell shape. So the structure of 3dxy, this is the x plane, this is the y plane, x and y plane. 3dxy, what is the diagram? Double dumbbell structure. Upper side above the y positive y axis plus sign, below the y axis negative sign. This is the 3dxy structure. Next, the structure of 3dyz. 3dyz, same procedure. This is considered y, this is considered z. What is the diagram of 3dyz? Upper surface positive, lower surface negative. This is the 3dyz. What is this midpoint name? What is the midpoint name? 4 lobes are meet at a point. This name is nodal point. Nodal point. This point name is nodal point. What is the meaning of nodal point? What is the meaning of nodal point? What is the meaning of nodal point? At which point of atomic orbital, the electron density, the probability of electron density 0. The probability of electron density 0. This point is known as nodal point. So 3dxy, 3dyz, 3dzx also be drawn. 3dyz also be drawn. What is the 3dzx shape? 3dzx. This sign positive, this sign negative. This is considered y, this is considered z. This is the name of 3dzx. 3dzx. Then 3dx square minus y square. What is the structure of 3dx square minus y square? This is y plane, this is x plane. What is the structure of dx square minus y square? This is one double dumbbell. This is the structure of this sign positive, this sign negative, this sign negative due to negative x axis, and this is positive axis, so positive sign. So this is the structure of 3D x square minus y square. Next 3D z square. 3D, what is the structure of 3D z square? This is the z plane, this is the y plane. 3D z square. That means this is the 3D z square. This is the structure of 3D z square. So the 5 empty space of D subcell are named as 3D xy, 3D yz, 3D zx, 3D x square minus y square, and 3D z square. The different type of hybridization, the different subcell are take part in the hybridization. So this is the complete structure and their nodal point. What is the nodal point? At which point of the atomic orbital the probability of electron density is 0. So we can summary in this time we read the ground state configuration of central atom in a given compound. First time, according to the electron fill up, according to Horn's rules. This electron fill up followed by Horn's rules. Then we take only valence shell configuration. The valence shell configuration, what is the valence shell? The outermost subshell of an atom in their atom electronic configuration. Then the outermost subshell is known as valence shell. The outermost subshell 3p, but you can justify the principal quantum number. This value is principal quantum number 3. Then the previous atomic orbital also 3. So 2 are valence shell because due to present their same quantum number. So we can take only 3s2 and 3p3, and the Horn rules follow for excited state 3s2, 3p3, and also kept in mind phosphorus has vacant d orbital. 3p next orbital, this is 3d. 3d contain maximum 5 empty space. This 5 empty space is known as, this is the name and the structure. Phosphorus can have vacant 3d orbital. Then next point, in excited state, that means when photon particle are fall on the metal surface, then electron are jump from the metal surface, but it is not easy to jump electron from the metal surface. This is the photoelectric effect phenomena. The incident wavelength and the threshold wavelength, threshold frequency are dependent quantity for this releasing electron on the metal surface. So 3D when excited state, that means when photon particle are fall on the ground, fall on the metal surface, then the pairing electron, are break down in the unpaired electron. That means one pairing electron are break down unpaired electron. The unpaired electron can place the vacant 3d orbital. So the configuration, final configuration, 3s, one electron are jumping from 3s to 3d due to vacant 3 orbital. Then 3p, total number of electron 3 and vacant orbital also p subshell contain vacant 3. Name px, py, pz, then 3d. One electron can jump from 3s to 3d due to vacant 3d orbital. This is the 3d orbital. So this unpaired electron can bonded with surrounding atom. Each unpaired electron bonded with surrounding atom. So the surrounding atom can bonded with the configuration of central atom used 1s orbital, 3p orbital. 3 chlorine are paired with unpaired of 3p electron. That means the orbital used 3p, px, py, pz. So sp3 and 1d orbital. So the hybridization name is sp3d. So the final hybridization sp3d. So this is the process of overlapping method for determination of hybridization of central atom in a given compound. First time you you write the electronic configuration in ground state of central atom. You can remind this, the phosphorus have vacant 3d orbital. 3d d subshell contain 5 empty space. The empty space known is 3d xy, 3d yz, zx, x square minus y square, and last 3d z square. And there draw their picture in previous. Then the electron fill up by the Hurndul's configuration. What is the Hurndul's? Each electron can occupy, single electron can occupy each orbital. Then next are pairing of each orbital. Then we take only valence shell. How I justify what is the valence shell? The outermost subshell is known as valence shell. Then according to rules, the 3p is valence shell, but their previous subshell, the principal counter number same. If principal counter number are same, then two R's are unite together valence shell. So valence shell are 3s and 3p, 3s to 3pt. Then the excited configuration, when the photon particle are coming out from the sunlight and fall on the metal surface, then the electron are excited. The excited electron can jump from pairing to unpaired condition. That means jump 3s to vacant 3d orbital. So this is the configuration. And the surrounding atom number is 5. They are bonded with unpaired electron. So this is the 5 unpaired electron and bonded with 5 chlorine atom. So atomic orbital are used, 1 s orbital, 3 p orbital, and 1 d orbital. So overall hybridization is sp3d. This is the complete procedure of overlapping method for hybridization. Please इसको छाप लो. Next topics. This is the procedure of overlapping method of any compound. Then the special type of hybridization. Then next the special type of hybridization. That means this is used for coordination compound in class 12. Special type of hybridization we can discuss about for coordination compound. That means special type of hybridization name is DsP2 and DsP2 and D2sp3. This is the special type of hybridization. It is applicable only not for normal compound. It is applicable only coordination compound in class 12 syllabus. Coordination compound are written this process. Always use third bracket. Suppose we consider Cr chromium NH3 whole 6 uppermost position 3 plus. This third bracket indicate the coordination compound. Coordination compound, first atom is known as central atom. In a the sphere of inside the third bracket, this is known as the sphere of inside the third bracket is known as coordination sphere. Then just in the outside portion, just the first, when the first third bracket is starting, then the first atom is known as central atom. Therefore chromium is known as central atom. Then in a coordination compound, the in between the two third bracket is known as coordination sphere. Coordination sphere contain first atom is known as central atom, and the remaining first inside the first bracket the compound is known as ligand. Then we know that in a coordination compound occupy coordination sphere. Then coordination sphere contain first which atom is present is known as central atom, and the remaining first bracket of molecules is known as ligand. Ligands are two types. One strong field ligand, other weak field ligand. When in a coordination sphere, when in a coordination sphere, when in a coordination sphere contain strong field ligand, contain strong field ligand, then hybridization may be hybridization either DsP2 or D2sp3. When, in which condition hybridization is known as DsP2? What is the meaning of this? When in a coordination sphere, that means this is the coordination sphere in between the third bracket. In a coordination sphere contain strong field ligand, that means this is the ligand portion. Central atom, after the central atom is known as ligand portion. So this ligand is, if this ligand is strong field ligand, then the hybridization either DsP2 or D2sp3. In which condition the hybridization is DsP2? When first bracket of ligand, when first bracket of ligand, which ligand? Strong ligand. Strong ligand suffix 4. If first bracket of strong ligand, inside the first bracket contains ligand are two types, strong field and weak field. If strong field ligand in between the first bracket and the lower number is 4, then it must be hybridization DsP2. If hybrid number is 4 and inside the first bracket the ligand is strong field ligand, then the hybridization must be DsP2. What is the shape of DsP2? DsP2 shape, hybridization का shape square planar. What is the coordination number of DsP2? Cn number, that means coordination number. Coordination number 4. The coordination number is 4 and the hybridization of sp2 shape square planar. Then when inside first bracket strong field ligand suffix 6, then it must be D2sp3 hybridization. What is the shape of DsP2? DsP3? This is the octahedral shape. What is the coordination number? Cn number 6. So this is the basic idea for the in a coordination compound. In between the third bracket is known as coordination sphere. In between the third bracket, first atom is known as central atom. Next, inside the first bracket, the compound or element is known as ligand. Ligand has two types, strong field and weak field ligand. When in a coordination sphere contains strong field ligand. This is the ligand. If it is strong field ligand, then hybridization must be DsP2 or D2sp3. In which condition the hybridization is DsP2? When the ligand portion is strong field ligand, that means the in between the first bracket contain ligand, but the type of ligand strong field ligand, then and the lower number is 4, then the hybridization is DsP2. Next, when in between the first bracket the ligand nature is strong field ligand is present and the lower number is 6, then D2sp3, and they are according to their shape. Then you must know that the example of strong field ligand, then you can justify what is strong field ligand, what is weak field ligand. First time you justify strong field ligand and weak field ligand, then you consider this procedure. So I given some example of strong field ligand. So I given some example of strong field ligand. Name cyanide group Cn, NH3 group Cl. This is the strong field ligand. You must remember this example of strong field ligand. Then maximum number of weak field ligand, but these 3 are most strong field ligand, then this ligand applicable for hybridization DsP2 or D2sp3 according to their condition. So we given an example of compound, this compound. Then this is the example of what is the hybridization of central atom in the coordination compound of central atom. So first time, step 1, we follow step 1, first determine oxidation number. That means oxidation number means first time step 1, first time the ligand, the nature of ligand. 1, the nature of ligand. The nature of ligand. Which ligand is present inside the first bracket? Ligand always occupy in between the first bracket. The nature of the ligand is strong field ligand. Strong field. Ligand is strong field. So, and then second, follow the inside the strong field ligand, and their number. What is the number? 6. What is the number? 6. If the first bracket contains strong field ligand and their number is 6, then the hybridization D2sp3. Then hybridization D2sp3, this compound. So the central atom contain D2sp3 hybridization. It is the quick short tricks for measurement the hybridization in short time. But the electronic configuration can also be seen. What is the overlapping method for coordination compound? What is the hybridization of central atom? It is the basic process in the MCQ question. If the in the coordination sphere, in between the first bracket contain ligand. If the ligand is strong field ligand and their number is 6, then the hybridization is D2sp3. Must be strong field ligand example. Strong field ligand, again right, strong field ligand must important. Strong field ligand are which are the strong field ligand? NH3 molecules, cyanide molecules and Cl molecules. This is the strong field ligand. Must be inside the first bracket contain ligand is strong field ligand. Then this procedure can be applicable. If weak field ligand, then normal procedure. If weak field ligand, that means suppose example chromium in third bracket of chromium, or suppose Ni, nickel, first bracket of CO, whole twice 4. This is the coordination compound, whole twice 4. This is the coordination compound. But CO is weak field ligand. Carbon monoxide is weak field ligand. If ligand is weak field ligand, if ligand is weak field ligand, then first follow the number, lower the number of ligand. Number 4, if weak field ligand is present in the coordination sphere, then the hybridization is normal hybridization. That means hybridization number 4, that is sp3 hybridization. This is the simple process for the MCQ question. If contain strong field ligand, then the special type of hybridization is used. If number 6, then the D2sp3. What is the example of strong field ligand? NH3, Cn and Cl. It is the strong. If coordination sphere contain weak field ligand, then the hybridization is normal hybridization. Then this is the coordination compound, but it is contain weak field ligand. For weak field ligand, the hybridization is normal hybridization. That means your syllabus hybridization. The weak field ligand outside the first bracket number 4. So if hybridization number is 4, then the hybridization is sp3. So normal hybridization can be used for coordination compound if the ligand is weak field ligand, but the ligand is strong field ligand, then the hybridization is named special type of hybridization dsp2 and d2sp3. It is the normal procedure for MCQ question, but the electronic configuration or overlapping method also prove that the special type of hybridization. This can follow the overlapping method for coordination compound. One more example, important example for in a coordination compound. platinum, third bracket of platinum NH3 whole 2 Cl2. This is the coordination sphere. This is the central atom. This is the central atom. This portion are ligand. This portion are ligand. But there are strong field ligand are present. There are strong field ligand are present. NH3 is a strong field ligand. So the hybridization of central atom. So the hybridization of central atom must be the hybridization of central atom must be special type of hybridization. That means either DsP2 or D2sP3. Then you can follow the total number of ligand. The total number of ligand Cl2. This is the formula. Platinum NH3 whole to Cl2. There are, after the central atom contain ligand. So there are two types of ligand, NH3 and Cl. Both ligand are strong ligand. Both ligand are strong ligand. So there are, then you follow the number outside the strong field ligand number 2, and this is the strong field ligand number 2. So total number, so counted total number of strong field ligand 2 plus 2, that means 4. So total number of strong field ligand 2 plus 2 4, but it contains strong field ligand. Then they used special type of hybridization. If hybridization number is 4, then the hybridization is DsP2 due to presence of strong field ligand. If this species, the ligand contains weak field ligand, but the number is 4, then the hybridization is normal hybridization. Then that means sp3 hybridization. This is the short method for MCQ question, but the process for the board exam for coordination compound, their electronic configuration and their pairing of surrounding atom, or this coordination compound pairing of ligand atom, ligand molecule species or ligand compound are coordinated with central atom configuration. This is the board exam for class 11 or 12. What is the special type of hybridization followed by overlapping method. This method also be applicable only for board exam, but not applicable only MCQ question. MCQ question, this help very easily to determine the hybridization of special type of hybridization. प्लीज इसको छाप लो किताब में. नेक्स्ट वीडियो में मैं द हाइब्रिडाइजेशन मेथड ऑफ कोऑर्डिनेशन कंपाउंड will be discussed, the overlapping method for coordination compound for special type of hybridization, how it is formation and it is procedure. Then the next video में I will discuss next video the topics hybridization of coordination compound for special type of hybridization. Thank you for watching.